All right, gang, Math 5130. Make sure I'm still recording here. Yeah, I had a glitch, technical glitch. But all right, I'm creating this video on the heels of the first video, which introduced to you confidence intervals for proportions. So the example was a little goofy, not that, diabetes issues All right, gang, Math 5130. This is, I'm creating this video on the heels of the first video, where I introduced to you confidence intervals for population proportions. But in that video, I just presented summary data. That's typically not how nursing or occupational therapy or health science research evolves. So let's go to StatCrunch and grab a data set from your textbook. And I want you to go down to births. And the very first thing we need to do when we look at this data set is it in proper format? And proper format means when I read left to right, I have cases. So this particular case this particular patient was from Albany Medical. Let's see what that actually stands for. Albany Medical Center Hospital. The insurance they used was Blue Cross. The sex of the baby was 0, so female. The length of stay was 4 days, and so on. So all the information when I read left to right is based on a case, which in this case appears to be the patient giving birth to a child. When I read up and down, I get the variables. Looks like this is total charge, birth weight, and so on and so forth. Now, for an illustration of a confidence interval for proportion, I need to concentrate on a variable that's categorical. So let's frame the problem here. Let's say that we are interested. Well, let's talk about what we can assume. First thing, let's assume that these, I believe 400, right, these 400 patients are randomly selected from these hospitals in a particular state, region, city, whatever it may be. And we would like to know the percentage of patients giving birth in this particular region who use Blue Cross insurance. So first thing I would want to do is I would want to go to proportion stats. I'd want to go to one sample, and I'd want to go with data instead of with the summary, because I don't have the summaries I did before. I actually have the raw data. So I want to select that. So I'm going to select my variable, insurance. Success is going to be Blue Cross, and I have to type that in exactly the way it's entered into the data set for obvious reasons. Come to confidence level, select 0.95, select standard walled. So when I compute, let's see what information that we get. First thing I get is insurance. That's the variable that we're analyzing. For this sample, 101 of the patients had Blue Cross out of the 400 total. The sample proportion, which I get by taking 101 divided by 400, is 0.25. So I can say that 25.3% of the patients in this sample used Blue Cross insurance for their stay. Standard error, I'm going to show you more about that in just a second. The lower limit of the confidence interval would be 21.0%. The upper limit of the confidence interval would be 29.5%. So we can say with 0.95 probability or 95% confidence that this interval, 21.0% to 29.5%, contains the population proportion of patients who uses Blue Cross insurance. Now, If we're going to do this problem in R, we run into a couple of caveats. First of all, and I'll try to explain this, and you're not going to like it. I'll just tell you right now. The code that we use here is called prop table, or the command. And we enter the data, or the summary data, directly. So I have 101 out of 400, so that's separated by commas. Then I need to let R know that I want it to calculate a 95% confidence level. And there's something called a correct method, and I need that to be false. Now, here's what you're not going to like. All right, what's going on here? Prop table. Oh, shoot. Gosh. That should be prop test, not prop table. Prop table is previous stuff. So my bad. First mistake I've ever made. If you believe that, I got a bridge I want to sell you. So when we run the correct command, prop test, you can see that the 95% confidence interval that we get runs from 21.2% to 29.7%, not what we get over here. Now, the reason is, and I don't want to go down too many rabbit holes here, but and of course the question you're probably saying, well, which one's right? Well, actually, technically, they're both right. This is a perfect example of why you must cite the statistical software package that you're using when you're reporting your results. Circle back to discussion forum post number 1. I think at the end of the first paragraph, may even been the second paragraph, I said that data was analyzed using R, and I gave the version that I use, and I cited it. And by the way, you can always get the citation in R using this. All right, but let's circle back to this because this is interesting. Why are they different? Well, the standard walled process uses a Z critical value. The one proportion test in R uses a T critical value. And those are different, therefore you get different confidence levels. So which one's right? You could report either one of these as long as you report the statistical software and cite the statistical software that you used. Now, if you want to, I think it's only fair to you to show how we can create this in R. What I could do if I want to create this in R, I can just kind of force it, so to speak. My p hat in this case is 101 over 400. The next thing I need is my critical value. And what I would do there is I would do a function called qnorm, and I would use 0.025 because that's half of my alpha value of a mean 0, standard deviation 1, because again it's a critical value from standard normal distribution. And I can create my standard error by taking the square root of p hat times 1 minus p hat divided by my sample size. Now, if this interests you and you want to learn more, your textbook does a nice illustration of these calculations, why and hows of it. At this level, I'm not interested in that. I'm just using this as an illustration. So when I do p hat, you can see that I get 0.2525, which matches the sample proportion over here. When I get the critical value, remember 1.96, now that should be a positive 1.96, so I'm going to have to make an adjustment. In fact, I'm going to go ahead and do that right now. So my new critical is going to be my critical value that I calculated times -1. And then my standard error, you can see, is 0.0217, which is exactly what we get over here. So if I want to calculate my confidence interval, I can do p hat minus my critical times my standard error, and I can do p hat plus my critical value times my standard error. So to make these calculations in R, I would just have to repeat this command, and it's very simple. As long as you don't make a typo or do something silly, this is easily done in R. But if I have the option of using StatCrunch or R at this stage, I'm probably going to use StatCrunch. All right, gang, it's all I got. Take care.